Good day, this is Engineer Ahmed Ragab from Egypt. Let me introduce my paper, Innovative Solar Photovoltaic Solution for Water Efficient Irrigation, a Comprehensive Algorithmic Approach, under supervision of Professor Dr. Abhanima bin Abi Zikri and Professor Dr. Ashraf Yahya. Acknowledgement. I would like to thank my God who shows me the way and makes me able to finish this work. I'd like to thank my professors. Motivation of the study: due to global recession and disruption of supply chains in many parts of the world, fuel prices in an unprecedented way went up. Also, there is a water crisis worldwide. Designing efficient solar pumping irrigation system will help developing countries to overcome fuel crisis and water crisis worldwide. Topics and objectives of the thesis. The study introduced a comprehensive model for a photovoltaic solar pumping irrigation system. The model integrates equations and features case study with outcomes. It merged principles from agriculture, irrigation, and PV solar engineering sciences. The proposed system is a modular simulator, aids PV solar engineers in sizing water pumping systems for different land types. Key objectives of the thesis: proposing an integrated model for photovoltaic solar pumping irrigation system, evaluating and simulating system performance based on solar generator modeling and water needs of the crops, analyzing solar PV pumping irrigation system design and results, recommendation to solve both crises. Methodology overview. In order to design any solar water pumping system, we need to determine water requirements of the crops. One of the most famous models is the Benha variation method, recommended by Food Agriculture Organization. We use this in this study. Agroclimatic zones, based on 10 years study of reference evapotranspiration values, is used in this study. Claim what platform evolution is used in this study to determine the weather data. A case study of 20 fedden is done in this study. Nodal modified surge irrigation scheme. The surge irrigation is used principally to overcome two issues: runoff of water irrigation and deep percolation of water for irrigation water. We modify this to be suitable for Egyptian environment and propose a novel modified surge irrigation scheme to make water reduction with 30%. Water requirements after calculation using crop water program is 204 cubic meter per decade, 10 days, and per 2 feddens for tomato in winter season, and for maize is 432. In summer season, we use double of this amount to overcome the intermittent nature of solar energy. The main algorithm is a solar generator simulation algorithm. It consists of 3 levels. Level 1 is to collect and process data from a free radiance data website, which is European Union, using the typical meteorological year from 2007 to 2017. It includes irradiant data, DNI, DHI, and GHI insolation data. This data is fed to isotropic radiance model and anisotropic radiance model, Louis and Jordan and Davis and Hay. The second level is to extract the solar parameter extraction of a solar cell or solar model. We use analytic approach proposed by Jabir Corpus and compare the results with results from Tau-Mau numerical model and the datasheet model. Finally, all of this data is injected to the solar system simulator proposed by Zikri, and the data is compared to the BVGIS Monnier model. This is the solar generator simulation approach used. And the second algorithm is the pump algorithm to determine water flow and head hourly basis in a year. It uses the data simulated from the solar generator and then injected to the pump algorithm to determine the output. Result and discussion. For the radiance model, we used anisotropic model and isotropic model, Louis and Jordan and Hay and Davis model, circumsolar model. The calculation based on 8,760 data point entry per year, and compared to the Monnier model used by the European Union. This is the insolation per square meter for each source and comparison between both studies. This is the total radiation per square meter hourly basis in a year using TEMI data. And this is a simulation comparison between the PVGIS Monnier model and the system simulated model. For 5-parameter level 2 5-parameter extraction validation, we use under standard test condition. We use we use Javert-Corpus analytic approach model with implicit equation in RS or series resistance. And under test condition, we simulate this and compare it with tau-mau 5 parameters extraction with numerical method. And compare all of these data to the simulation under standard test condition of data sheet. 99.9% is validated. The table shows the simulated and PVGIS system solar generation per year monthly. This is the ratio between PVGIS simulation data generated and the study generated energy. For the pumping system results under discussion, the total water requirements is 864 cubic meter per decade for 2 feeden, and for in winter per decade in summer, and 408 cubic meter in per decade for winter for 2 feeden. We use in pumping system modeling. We use the NREL, the National Research Energy Laboratory of USA PV pumping system. We modify it with the efficiency curves used in this study. This is the different heads and discharge of the pump with different flow rates and in 3-dimension discharge versus speed of the pump versus head of water. This is the efficiency curve we design in this study using the least square error and polynomial method. This is the hydraulic power submitted from pump impeller to water, and this is the summer and winter average daily discharge needs and daily discharge. Conclusion: analytic approach used to extract solar parameter is very accurate, 99.9 validated. TEMI data used from year 2007 to 2016 study for 1 year analysis is not accurate enough compared to the current year. The algorithm used in this study are agile, modular, and many other models could be used and plug in instead of applied ones and tested. Solar pumping irrigation system cannot be used as a standalone system except if water is stored as a days of autonomous or hybrid system is used. Any question? Thank you for your listening.